Okay. What we're going to do is we're going to look at the line which is perpendicular to the line that goes through AB. If you think about the question, right at the moment, you are able to tell me quite easily, I'm sure, how we would find the equation of the line AB, the equation of the line AB. What would we do? We've got coordinate A, coordinate B. What is the steps required to get us to, yes?
x1 plus x2 divided by 2.
Okay, there's only a few things wrong with that. Okay, it's upside down and also you added instead of subtracted. You couldn't have got that more wrong. But not wanting to shatter your self-esteem or self-confidence, do you want another crack? No, okay. Anyone else? No, Gilchrist is. No. Yes. Okay, first option is we could use the calculator method. Okay, and put those points into your graphics calculator, get it to graph them, get it to tell you what the gradient was that way, okay, because we need the gradient. Or we could do the gradient equals y1 minus y2, which is what you said, but upside down and you added. I'll just write that again, y2 minus y1 over x2. That. So this thing here, y2 minus y1 is the rise, it's this bit here, and the run is that bit. y2 minus y1 over x2 minus x1. Whichever way you feel like doing, I actually think the rise over run, when you sort of draw it, you can sort of see the rise and you can see the run, and so you can work out the gradient really quickly. If you don't draw it, substituting into that's probably relatively quick. If you want to use the graphics calculator thing, probably require some practice. Thank you. Excellent. I think the graphics calculator thing is tremendous, but it requires quite a lot of steps, and it might be just quicker doing this, but it's entirely up to you. The important thing is, whatever the gradient is, this is the gradient of AB. Now, that's great if you want to work out the equation of the line, which goes through there. That's meant to be a straight line passing through AB. What formula do you use to go with that? Y minus y1 equals gradient x minus x1. That is what we're going to use to work out the equation of that line. Now, if the question says, what is the equation of the line which is perpendicular to that line, then we need to know what the gradient of a perpendicular line is. Okay? And it's very, very simple. There is a relationship between the gradient of a line and the gradient of its perpendicular line. Okay? And that is this one here. The gradient multiplied by the gradient of the line that is perpendicular, when you multiply them together, you get -1. That is it. You have to remember that, but it shouldn't be too hard. So, for instance, yeah, that means perpendicular, okay, at right angles. So the gradient multiplied by the gradient of the line which is perpendicular comes out to be -1. So, why? Well, I can prove it, but just take it. Here's an example. Let's draw a line which has a gradient of, let's make it 5, and this is, any other random numbers? 10. Okay, of course it's not drawn to scale, it's 5, and there it is. Now, in fact, let's make it 5 and 1. Now it is drawn to scale. There's the point 5, 1. What's the gradient of that line? 1 over 5. Okay, gradient equals 1 over 5 because we've got a 1 over 5. Now, a line which is perpendicular to that, which is obviously at right angles, will go there. that's at right angles. Near enough, yeah, sort of. And I'm suggesting to you, that without proving it, that if we swung this point here around 90 degrees,
So it's the opposite.
it would end up there.
I said that, sir. I said opposite.
And
Opposite day.
yeah, I'm not quite sure what you meant by that. But the point is, what is the gradient of the blue line?
5 over 1. Oh, 5 over negative 1.
Yeah, which to most of us is just minus 5. So it's rise, which is 5, over run, which is -1, 5 over -1, or the gradient of this line, which is perpendicular to the black one, is minus. And you will notice, just by a straight using the rotation thing, -5 times a fifth is -1. So it means that if we know the gradient of the line joining going back to here, if we know the gradient of AB, which of course is that rise over run thing, the y2 minus y1 over x2 minus x1, or the calculator method, whichever way you want to do it, as soon as you've got the gradient of the line joining that point, you instantly have the gradient of the perpendicular line. Okay? And that's it. So, as an example, I'll just give you an example here. If we've got the points A2 minus 1 and B5, 4, and the question says, find the equation of the line perpendicular to AB passing through A. Okay, so what we've got is this. There's the question. We've got 2 points. We've got A and B somewhere. And we want to work out, say that's A. Yeah, it doesn't matter. Just imagine you've got A and B, 2 points. What we're going to do is we're going to work out the gradient of AB, which enables us to work out the gradient of the perpendicular. That's sort of perpendicular. And because we know it's got the gradient of the perpendicular, we're then going to work out the equation of the line, the perpendicular line that passes through A. That will be that one, in that order. Okay? Yeah, because obviously parallel lines, same gradient. So let's do this. Let's just go back to this. What's the gradient of AB? M, AB. When you do your working, I'd like you to use this sort of thing here. M gradient, AB means the gradient of AB. It's pretty nice and clear, shorthand stuff. What's the gradient of AB? What's y2 minus y1? Y2.
Minus and minus is a positive. 5, so it's 5.
5 over?
1.5 over 5 over 3.
Thank you, 5 over 3. Y2, take away y1 is 5. X2, take away that is 3. 5 over 3. What's the gradient of the perpendicular line?
3 over 5.
Close? Minus 3 over 5, because when you multiply it has to come out minus 1. So if we've got the gradient of minus 3 over 5, yes, we'll just have a pause while we check out that group of girls going for the toilets. Now, what's the equation of the line which has a slope of minus 3/5? Okay, we started with 5 over 3, turn it into minus 3 over 5. Now we've got that gradient. We've got point A, which is 2, -1. We just substituted into our standard formula. Y minus that equals gradient x minus. There it is. Standard substitution into our y minus y1 equals mx minus x1. This time we're using m for the perpendicular, not m for the parallel. That's all there is to it. Rearrange that, it's all done. Okay?